Here is another word problem that we need to be able to solve with some calculus. The plane is flying at an altitude of 4 kilometres. That will take it directly over radar. So here's my feeble attempt at a plane and a tracking station. S is decreasing, so S is the distance from the plane down to the tracking station as a direct line at a rate of 250 kilometres per hour when S is equal to 6. So if S is the distance, we know that ds dt, the rate of change of the distance with respect to time, and that's rate of change of distance with respect to time. If it is decreasing, it'll be minus 250, and that's when S is equal to 6. And we're asked to find the speed of the plane. Now, the distance that the plane is, it's flying at a constant altitude of 4, so it is actually going on that path, parallel to the Earth. So if you like, we could draw a right angled triangle here and make that 4. It'll be the same as on that side. And if we call that x, so let x be the displacement of the plane. So we are asked to find dx dt. That's basically what we're asked to find, dx dt. And you look at it and you say, well, what have we got? Chain rule? No, I don't like that. I don't think you can link S and X with that, and that's going to... So what we'll do is, because we've got a right angle triangle, that's a little trigger to say, oh, right angle triangle, we might use Pythagoras. How are these related? And we know that S squared is equal to x squared plus 4 squared. So we can then differentiate right through with respect to time. Now when we find the derivative, because S is changing over time, it's a bit of implicit differentiation. So we've got 2s ds dt equals, so we're going derivative with respect to time of each of those terms. So we go 2s ds dt, derivative of x squared is the same thing again, x is changing over time, so it'll be 2x dx dt, and then the derivative of 16 will be equal to 0, derivative of constant is 0. That will give us a good idea of what's going on. We know what ds dt is, we've got that. We know that S is equal to 6. So we've got that. This is what we're trying to find, but we need to find that to be able to find dx dt. Can we find x? Of course we can. If that's an S, not a 6. So it actually is a 6 as well, so S is equal to 6. So, so we need to find x. Now how do we find x? Right angle triangle. So we've got 6 squared equals x squared plus 4 squared. 36 equals x squared plus 16. Take the 16 over there and we get x squared equals 20, so x is equal to root 20. That'll give us x, so I can then substitute in there. So we've got, go back and do our substitution in here, so we can find dx dt. We've got 2 times 6 times ds dt. ds dt is times negative 250 equals 2 times x, 2 times root 20, and then we've got dx dt, which is what we're trying to find. Divide right through by 2, both sides. So this will be negative 1500 is equal to root 20 dx dt. And from that, if we divide right through by negative 20, root 20, so we've got negative 1500 on root 20 is equal to dx dt. And if you use your calculator there, you'll find that that is around about, I think, 335, so negative 335 kilometres per hour. Alright, so that is what is the speed of the plane? dx dt is the speed of the plane, is negative. What do we denote the negative? How can we put some meaning to that? Basically, the plane flying from here, as it gets closer to the distance x from straight above there, is getting less and less, so it is decreasing. The dx dt is negative, means that the distance is getting less. So speed, since we don't have positive and negative, of the plane is 335 kilometres per hour. Okay, so we really, with these types of questions, we've got to use every bit of information that we've got. Don't throw out some of the older stuff that you learned about Pythagoras and all that sort of stuff, because that comes back in as well. Be prepared to do some differentiation, some implicit differentiation. Identify what you know, and then try and work out some sort of relationship between everything, and then substitute those values in.